Hi friends, let's start geometric progression. So we have already discussed what is geometric progression and we have seen basic examples where we have found out the values of x. Okay, so we know that the GP is nothing but having the common ratio. Okay, so what is general GP? So let's find out. So first of all, let me take one simple example. Based on that, we'll find out the GP. So the best example, the simplest example I can take is 2, 4, 8, 16. So what is this? It is 4 by 2 is 2, 8 by 4 is 2 and 16 by 8 is 2. Means this common ratio R is nothing but Tn plus 1 upon Tn. Please remember that it is next term divided by previous term. Okay, don't take R as a 2 by 4. The R will be wrong in that case. So R is always the next term divided by the previous term. Okay, so let's start. So in this case our A is nothing but 2 and R is nothing but kitna hai R? R is nothing but again 2. So how you get the first term with the help of these two, A and R? How you get with the help of these two, A and R? So first term I can write as only A. The second term I can write as A into R. So 2 into 2 gives me 4. The third term I can write as A R square. Please verify. A is 2, R square becomes 4. So 4 into 2 is 8. The fourth term I can write as A R cube. So 2 cube is nothing but 8 into 2 is 16. Okay. Now if you observe carefully, the first term, in the first term, what is the power of R? R power is 0. In the second term, the power of R is 1. In the third term, it is 2. In the fourth term, it is 3. So if you expand this, what will be the power of R in the nth term? Sorry, what will be the power of R in the nth term? That will be R raised to power n minus 1. So this is nothing but the nth term. Getting? So this is first term, second term, third term, fourth term, and this will be the nth term, in which the power of R is nothing but n minus 1. Getting? So this becomes our general T nth term of an GP. So if somebody asks you in this GP, can you find out the 10th term? Yes, definitely we can find out the 10th term. So T10 will be what? A R raised to power 10 bola hai, to 9, 10, 10 minus 1 is 9. So which will be 2 into 2 raised to power 9, which is 2 raised to 10, which will be 1024. Yes, this is our answer. Okay, very good. So the general terms of NAP becomes AR square, and if you continue this, the nth term will be AR raised to power n minus 1. Next, the nth term we have already discussed. What is nth term? Tn is equals to AR raised to power n minus 1. Okay, sum of the first n terms. Okay, let me take a new slide. So again in a GP we have two types of progressions. One is finite progression and other is infinite progression. Finite progression means what? Let's take the same example. If the GP is like this, 2, 4, 8, 16 and 32. If the GP has only these 5 terms, then these type of progressions are known as finite progressions. Okay, these type of progressions are known as finite. Whereas the infinite term means what? It is 2, 4, 8, 16, 32, dot dot dot. Okay, these type of progressions are known as infinite terms. We don't know how many terms are there. In the finite we definitely know there are only 5 terms. There can be any number of terms, but they are countable. Infinite means non-countable terms. Okay, again, so GP has divided into two parts based on the number of terms. One is a finite and other is infinite. There is one more type of division we can do based on the value of R. So first take the example 2, 4, 8 and 16 finite. Okay, And let me take another example where 1 by 2, 1 by 4, 1 by 8 and 1 by 16. Can you tell me whether this progression is GP? Yes, definitely. See here, 1 by 4 by 1 by 2 is nothing but 1 by 2. 1 by 8 by 1 by 4 is again 1 by 2. 1 by 16 by 1 by 2 is again 1 by 2. Okay, here the common ratio R is what? 1 by 2, and here the common ratio R is what? It is 2. So based on the value of R, your geometric progression again divided into 2. The first example is where your mod R value is greater than 1, and the second example is what? Your mod value is less than 1. Okay, please remember these two type of geometric progressions. One is finite and infinite, and other is mod R values are greater than or less than 1. Okay, now based on this, let's find out the sum of first n terms of an GP if your GP is a finite. Okay, and the case number 1 is where your mod R is greater than 1. Okay, so your Sn becomes a r raised to power n minus 1 upon r minus 1. And for the case 2, what is case 2 is mod R is less than 1, and for this a into 1 minus r raised to power n upon 1 minus r. That's it. So क्या करना है इसको? Just इसको उल्टा लिख दो. How you will remember? So subtraction, always remember the subtraction should be positive. R is greater than 1, so subtract 1 from R. R is less than 1, so subtract R from 1. Okay, very good. So these two are very important again. If there are infinite terms in a GP, then what will be the sum? So sum to the infinity is always equals to a by what? Sum to the infinity. When your GP is infinite, whenever your mod R value is less than 1, then only your sum will be infinite. Okay, so it will be 1 minus R. Okay, so let's start the next one. So please remember these three formulas, 1, 2 and 3, very helpful while solving the questions. Next, so let's have fun with geometry progression. So fun means nothing but the properties we are looking at. Okay, the multiplication and division of k to all terms of GP gives new GP with the same R. So let's take example 2, 4, 8, 16. Okay, so if I multiply each and every term by next again 2, so what will be the next GP? Will be 4, 8, 16 and 32. See, okay, so next GP is again 32. Whether this progression is in GP? Yes, it is in GP. What is the R value in the next? What is the R value in this new? It is again 2. Okay, so R is again 2. So means multiplication and division does not change your GP. That common ratio will remain same. Okay, next properties. The reciprocal of all the terms of GP forms new GP. Just now we have seen. Suppose we have 2, 4, 8 and 16. If I do reciprocal of each term, 1 by 2, 1 by 4, 1 by 8 and 1 by 16, then this progression is also in the GP. But what will be the common ratio in this case? Common ratio is nothing but 1 by 2. यहाँ पे कितना था? 2 था. So if you do reciprocal of all the terms, your R will also reciprocate. Okay, inverse हो गया. So it forms a new GP with R actually original R का inverse हो जाएगा. Okay, so the next property is what? If each term of GP raised to same power, new GP forms. Okay, so let's take one simple GP. The example is what? Suppose it is 10, 100, 1000, okay, 10,000. So if I raise all the powers to 2, so x raised to 2, so क्या होगा? 10 to power 2 is 100. 100 का power 2 is क्या? It is 0 0. Then 1000 का कितना हो गया? 3 0 है, तो उसको फिर से 3 0 ऐड कर दो. So this is nothing but your next GP. So it is, this was our original, this is our next. So whether this is in again progression, let's try to divide. यहाँ पे 4 zeros है, यहाँ पे 2 zeros है. So what is the division is 2 zeros. यहाँ पे 6 zeros है और यहाँ पे 1 2 3 4 Okay, so again if you divide you will get 100 only. Means what? This is also in the GP, but now in this case what is R, which is nothing but same 10 to the power 2. जितना इंडेक्स है उतना इंडेक्स से R आपका बढ़ेगा. यहाँ पे your R was originally 10. Now your R becomes 10 to the power this index. Okay, getting? Very good. So if all the terms, suppose the question is like this, if x, y and z are in GP with the common ratio R, and the new GP has formed with the where the all terms are raised to the power p, then what is the new R value? So new R value कितना रहेगा? R to the power p रहेगा. Getting? Good. So the fourth property is product of terms equidistant from beginning to end is the same and is equal to product of the extremes. This we have already seen in the GP. That same concept is there. Again here 2, 4, 8 and 16. Okay. What is the product of these two? 16 into is 32. What is the product of these two? It is 32 again. Means the product is equidistant. First from beginning, first from end. So and second from beginning, second from end, third. Okay. The product always remains same and this product is always equal to the product of extremes. मतलब 2 and 16 का जो भी product रहेगा वो बीच में के जितने भी values रहेंगे उनका product same रहेगा. Okay. The logarithm of GP terms forms a new GP. This is again important. One question has appeared based on this concept. Okay. So logarithm of GPs. So let me take the simple GP. Okay. Suppose these are the 4 terms in an GP. Okay. Then logs of these terms means log of 10, log of 100, log of 1000 and log of 10,000 means what? Log 10 is what? 1, log 100 is 2, log 1000 is 3, log 10,000 is 4. See what I am getting here, 1, 2, 3, 4 means what? If the GPs, if the terms are in GP, then their log values will becomes an AP. Vice versa is also true. If you have the terms of AP and if you take the log, then AP becomes GP. Okay, ऐसा याद रखो. AP if you take log, then it becomes GP. If GP, then if you take log, then it becomes AP. Important one. Okay, so based on this there was one question in your exam. So next is what? If A, B, C are in GP, then B is under the root of, sorry, it is not AB, it should be AC. Okay, under the root of AC. Okay, and this B is known as a geometric mean. Will see all the 3 means in the next upcoming videos. The next, if G1, G2, G3, B and GMs between A and B, then your G1, G2, G3 and Gn will get the values like this. Okay, means your series is like this, G1, G2, G3, okay, dot Gn comma B. Then what will be the value of this? G is nothing but Gn is nothing but A into B by A raised to power n upon n minus 1, sorry, n plus 1. Okay, so we'll see the questions based on this. Okay, so if you like this video, please hit the like button, share karo and write down your views in comment section and subscribe to my channel to get more videos. Thanks for watching this video.